So this is the physics, physics and work. Yeah. So on top about work, work is the product of force and distance moved in the same direction. So saying that work is the product of force and the distance moved in the same direction. So this is a definition for work. So I saying that work is the product of force and distance moved in the same direction, which means the force and distance must move in the same direction. So I'm saying that work is equal to force times distance. So in symbol, we're saying that work is equal to force times the distance. So this force need to be Newton and the distance need to be in meters. So if the distance is in centimeters or kilometers, try by means to convert it into meters. Then the force must be in newtons. Then when we have these two now, we are going to call joules, which means work is measured in joules, which is given by capital J. So if the question demands you to find work, the answer must be in joules. And this is a formula for work. So sometimes they cannot give you the force. So for us to find force, we can use the formula. The force is equal to mass times the acceleration. So this mass must be in kg and acceleration in meters per second, or Newton per kg. Yeah. So apart from that, we can also use, we know that this one, weight is same as force. So weight is also mass times gravity. So this is acceleration due to gravity, and the acceleration due to gravity on Earth, we know that it's 9.8, which is same as 10 meters per second squared. Then on Moon, we know that's 1.6 meter per second squared. So these two formulas can be used to find weight or force in a situation where the force or weight is not given in the question. So the weight is equal to force times the distance. Now, when we try to follow the definition for work, we say that work is the product of force and distance moved in the same direction, which means for work to be done, the force and distance must move in the same direction. And so, for example, here, I can say, if this person, example, like this person here is pushing a car, pushing this car. And since the force of this person is going in this direction, is a force, and the distance is going in the same direction, this distance. So as you can see, the force and distance are moving in the same direction, which means there's work done. So work can only be done when the force and distance are both moving in the same direction. But here, there's no, so here there's work done, but here there's no work done here. When this person is carrying a bucket of water here, on his or her head. So as you can see, the force distance is going in this direction, and the force of this object, the force is going downwards. So force. So as you can see, the force is going downwards, the distance is going also in different direction, which means here there's no work done. Work can only be done when the force and distance are both moving in the same direction. For example, if someone's pushing a box on the floor, and when someone's pushing a vehicle, which means there's work done. But here, the example, when someone carries the bucket of water, which means the force is going down, and the distance also going in a different direction. So it means there's work done. So here there's no work done because the force and distance, they are not moving in the same direction. So from the few explanation and examples that I've given, including the formula, we can now able to calculate some questions on work. Apart from that, under the same topic work, we need to know the formulas for the linear motion. So the first formula is v squared is equal to u squared plus 2ax. So this v is the velocity of an object, which is final velocity, and u is the initial velocity, and a is the acceleration. Sometimes can be the acceleration due to gravity, which is a g, and x stands for the distance. This is a distance. This is the distance here. Okay. The other formula is x, which is the distance, is equal to ut plus 1 over 2 at squared. So x is our distance, initial velocity and times time, plus 1 over 2 a acceleration and t the squared, which is time taken. Then apart from that, you can say x is equal to which is acceleration is equal to v minus u over time taken. So this is the formula also for acceleration. So as we calculate questions on work, energy, and power, we also need to know these equations, because sometimes they can ask us to find the work done and the distance not be given. So for us to find the distance, we can still use this formula or this formula. So I'll do some examples here. I'll do some examples quickly here. The first question is saying, number 1, a force of 5 Newton acts on a 3 kg brick moving 8 meters horizontally from rest position. Find the work done. So they want us to find the work done. So they're saying that a force of 5 newtons acts on a 3 kg, this mass, brick moving it 8 meters, this is distance horizontally from rest. Find the work done. So as I said, you know that work is equal to force times distance. So a work is equal to, so our force in this question, our force is this one, which is 5 newtons. So 5 newton here. The distance given in the question was 8 meters, so 8 meters. So which means there's no need for us to use this 3 kg. So now we say work is equal to the 5 times 8, which is 40 joules. So as I said, work is measured in joules, so 40 joules. Okay. Then I'll go to the next question, question 2. Question 2 is saying, a man pushes the big stone through 10 meters and exerts the force of 25 newtons. Find the work done by the man. Okay, so we have a man pushes the big stone through 10 meters. So this is distance given, and exerts the force of 25 newtons. find the work done by the man. So we need to find the work done. So we know that work is equal to force times the distance. So now, a work is equal to, what's our force in the question? So the force is 25 meters, so we have 25 here, times distance, we have 10 meters, we have 10 meters here. Okay? So now we say work is equal to 25 times 10, it is 250 joules. Don't forget, we're finding work, so work is measured in joules. So this is our final answer for this question. Then I'll go to the next question. Question 3. A crane lifts a weight of 200 newtons through 50 meters. Find the work done by the crane. Okay, so a crane lifts a weight of 200 newtons through 50 meters height. Find the work done by the crane. So we know that work is equal to force times the distance. Okay. Then our work is equal to, the force given in the question is 200 newtons. Distance is 50 meters. Okay. So now we say work is equal to 200 times 50. So 2 times 5, which is 10. 1, 2, 3, so 3 zeros. So that's will be 10,000 joules. This will be the final answer for this question. Then I'll go to question number 4. I'll go to question 4. Before reads 4. A crane lifts a car of mass 500 kg through 5 meters. Find the work done by the crane. Then we have G is equal to 10 meters per second squared. So this is acceleration due to gravity. So again, I'll still use the same formula, which says work is equal to force times the distance. So now, what I'm going to do here, I know that work is equal to, do we have force in the question? No, we don't have force, but we have mass. So as I said, the force is equal to mass times acceleration. And I said that force is same as the weight is equal to, this is weight in fact, weight is equal to mass times the acceleration, which is G, gravity. Since the gravity is given here, so we're going to use mass times gravity, which is same as mass times acceleration. So acceleration will get the one which is the acceleration due to gravity, which is the 10. So we say weight, which is equal to same as force, which is equal to mass times gravity. So our mass in the question, the mass is 500 kg. So 500 here times the gravity is 10. So get 10 here. So multiply this time this to be 5,000 newton. So this will be our force, which is same as the weight. So now force is this number now, which is a 5,000 here times the distance given in the question. Also our distance 5 meters here. Okay, good. So work is equal to now 5,000 times 5. 5 times 5, which is 25, and this will be 25,000 joules. So this will be the final answer for this question. Okay, so I'm going to question 5. go to question 5. Question 5 reads, a car of mass 1,000 kg is accelerated at 2 meters per second squared from rest in 20 seconds. 20 seconds. Find question A. I'm saying find the force of the car. Okay, so now that find the force of the car. So a car of mass 1,000 kg is accelerated at 2 meters per second squared from rest in 20 seconds. So here what we have here, so here we have right data here. We have acceleration, which is 2 meters per second squared. We have mass, which is 1,000 kg. Also have the initial velocity we have, since they said from rest, so it means our initial velocity is equal to what? 0 meters per second. Okay? And also have time here. The time is what? The time is 20 seconds. So these are the components that we have, which is data. So data, we have acceleration, we have mass, we have initial velocity, and time taken. Okay. So now, question A is saying that find the force of the car. So you know that the force is equal to mass times the acceleration. So force is equal to our mass. We have this number, which is 1,000 here. Acceleration, we have 2, which is our 2. So force will be equal to this time. This will be 2,000 Newton. So this will be our force. Okay. Then we go to question B. Question B is saying that B is saying find the distance traveled by the car in this period. Okay, so question B, they want us to find the distance traveled by the car in this period. So, as I said, even on work, energy, and power, we can still use the formula on the linear motion. So, since we have the initial velocity is 0, the time taken we have. So, the best format to use here, you can use this format. You can say x, which is distance, is equal to ut plus 1/2 at squared. Because we have initial velocity, the time we have, acceleration due to gravity, even this one acceleration, we have acceleration is what? 2. I mean, time taken we have. So we say x is equal to initial velocity is 0, so put 0 here. And the time taken here is 20 seconds, so put 20 seconds here, plus 1/2. So our acceleration we have 2 here, and time taken we have 20 here, then squared here. So now we say x is equal to 0 times 20 to be 0. This and this cancel. So 20 times 20 we have 400 meters. So the answer will be 400 meters. Then from there now we go to question C. Question C here. Question C, which says find the work done by the car in this period. Okay, so they want to find the work. So we know that work is equal to force times distance. So work is equal to force. The force that we found on question A, which was 2,000, times the distance that we have calculated. which is 400. So now we multiply this times this. So work is equal to 2 times 4, which is 8. Then we have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So it means we have 800,000 joules. This will be our work done. So this is how we are supposed to do this type of questions. So the next part that we'll do is energy. So I'll make another video on energy. So this is the first part on work. Thank you very much.